So in this detailed tutorial, we are going to learn about a very important tool called Wireshark. We are going to start from absolute zero. After getting basics out of the way, then we will cover a few intermediate level topics as well. So let's look at the agenda for this tutorial. What Wireshark is and why it is used. Then we will explore basics, make few required changes and understand its core components and functionalities. Then what promiscuous mode is and how to enable it. Then we will understand what filters are and its types. Then we are gonna learn the most used 20 or probably more filters to find the exact packets or information you want. Wireshark is an open source packet sniffer and analysis tool. It captures packets on the local network from each connected device to the network. Wireshark is used for monitoring traffic, troubleshooting network issues, inspecting individual packets, and you can also detect suspicious activities in your network by analyzing packets. Wireshark is a must-know tool for network administrators and cybersecurity specialists. Wireshark is pre-installed in Kali Linux and Parrot OS. You can download Wireshark for Windows and Mac as well. Its interface and features remain same across all the operating systems. So it makes no difference in which operating system you use Wireshark on. You can download Wireshark from this page. Link is in the description. Installation steps in Windows are very straight. After installing, start Wireshark. So in order to start Wireshark in Kali Linux or other distributions, type sudo wireshark and hit enter. So when you start Wireshark, first thing you have to do is select your network interface card, meaning how you are connected to the internet. As you can see, I have a lengthy list of interfaces. Most of them are created by my virtual machines, so you can ignore them. They are not real physical cards. This list is going to be different for everyone. In most cases, either you will be using internet with Wi-Fi or Ethernet. Wireless card is represented by Wi-Fi in Windows. As you can see, in Linux, wireless card is denoted by WLAN 0 and Ethernet card is represented by ETHO in Linux. In Windows it is simply Ethernet. Alright, so I am connected to internet with the wireless card, so selecting Wi-Fi. As soon as you select your interface, Wireshark basically starts capturing the packets. As you can see, for now it is probably talking to my virtual machines. So guys, first thing we are going to do, we will understand the core structure and functionalities of Wireshark. So go to the view menu. Basically lets you decide the components that you want to appear in your display area. As you can see, all the essential components are pre-selected for you. First three selected are main, filter and status bar. This is the status bar. At the bottom it displays a summary of captured and lost packets. This is the filter bar for filtering packets according to port numbers or protocols. This is the main toolbar. It contains functions that you are going to use frequently. Alright, so this red button basically stops the current session. First button starts a new session. As you can see, it is asking me to whether I want to save the currently captured packets. You can click on save and give a file name. You don't have to write any extension here. And this button restarts a new session. Again, you can save if you want, and you can also choose to continue without saving. And then we have this capture options button. For now it is not working because our session is running. If you stop the session, you can access the button. It basically lists all the interfaces, as you can see, in detail. We will get back to capture interfaces option later in the video. For now, close it. And this button opens an existing file. If you already have a Wireshark file, then you can open with this option. And this button saves the current file. Cross button closes the current file. This button is for refreshing or reloading, as you can see. And this search button basically lets you find the packets. As you can see, you can use different search terms here. You can use string, hexadecimal, or filters. Okay, we will learn about filters in detail. For now, this is not that important. Click on cancel, and then we have these two left and right arrow buttons. These are just like your up and down arrow keys. They are used for navigation. For example, if you click on any packet, then you can navigate up and down with these arrows. Then we have this go to specific packet button. If you click on it, let's say you want to go to the first captured packet, write your number, click on go to packet. As you can see, the first packet has been highlighted with the background color. These up and down arrow buttons take you to the first and last captured packet. If you want to go to the last captured packet, click on this button, as you can see, and for the first captured packet, click on this button. This button automatically points to the last captured packet during live session. So by default, this button is enabled. And then we have this colorization button. As you can notice, guys, we have captured packets in different colors. That is because Wireshark has assigned different colors to each protocol for better readability. Okay, if you disable this button, as you can see, now all the packets are looking the same. If you want to find out which protocol is associated with which color, go to the view, click on coloring rule. Now as you can see here, guys, you can basically find out the packets color. As you can see, UDP has light blue background. You can browse the rest of the packets here. You can also customize the color. For example, let's say you want to change background color of TCP packet, then click on the packet and click on background, select your custom color, click on OK. In order to change text color or foreground, click on foreground, then select color, click on OK, then click on OK. And then we have these plus and minus icons. Plus icon basically increases font size of your texts, as you can see, and minus icon decreases the size, and this icon sets font size to the default. As you can see, let me increase. And then we have this last button. It basically helps you to resize the columns. For example, let's say you want to make more space for destination, then you can basically drag and drop from either side of your column, just like that. Okay, you can also swap the columns. Let's say you want to bring protocol column here, then you can do it just like that. Now go to the view. Now next three selected components are packet list, packet details, and packet bytes. This is the packet list where Wireshark displays all the captured packets, and this is the packet detail. If you click on any packet, then down here it displays a detailed information about the selected packet, and down here we have packet bytes. Here information is displayed in raw form. As you can see, for now it is displaying in hexadecimal. You can change it to, let's say, binary. Right click on as bits. As you can see, we have information in pure binary. Let me revert back to hexadecimal. Now let's understand what these columns mean. So first column, number, it displays captured packets in serial number, as you can see, in ascending order. And then we have time column. Time column basically displays timing of captured packet when it was captured. As you can see, for now time format is not readable at all, so let's make it readable. Go to the view, click on time display format. From first half, select time of the day. Again go to view, click on time display format, select seconds. Now as you can see, guys, we have much better format now. And source column displays the IP address of device who sent the packet or where packet originated from. And destination column displays the IP address of device who received the packet or where packet was delivered. And protocol column displays the type of protocol, whether it is TCP, TLS, or ARP. And length column displays packet size in bytes, and info column displays a very brief information about the packet. Alright, now guys, let's understand what promiscuous mode is. Go to the capture, click on options. You can also access this capture interfaces option through this button directly. So this capture interfaces displays all the interfaces with much better controls. As you can see, our current interface is being highlighted with background color. Down here, as you can see, enable promiscuous mode on all the interfaces. So question is, what promiscuous mode is? Promiscuous mode captures traffic going through all the devices connected to the network. By default, our network cards are not designed to listen the traffic flowing on other devices. Your network card only listens traffic which is specifically directed to your MAC address. So promiscuous mode enables your network card to listen and monitor traffic on all the devices on your network. Alright. By default, promiscuous mode is enabled. If you disable promiscuous mode, then it will only capture or monitor traffic within your own computer, alright, or device. So as you can see here, you can decide on which interface you want to enable promiscuous mode on. As you can see, by default it is enabled on all the interfaces. You can select accordingly. Now click on close. So guys, before moving forward, I want to explain very briefly what all these layers mean, what information they represent. I will keep it very brief because if I go for the detailed explanation, then each layer is going to take at least 10 minutes. So this TCP layer is responsible for establishing connection between two computers. As you can see, we have basic information about the connection. This is the source port, that source computer or computer who initiated the connection used for connecting with destination computers. As you can see in IP layer, this is the IP address of computer who initiated the connection, and source computer used this port number to establish connection with destination, and this is the IP address of destination, and destination computer used port number 443 to accept the connection. Then we have this Ethernet layer. Ethernet layer basically displays the MAC address of source computer and destination. So this is the MAC address of source computer who initiated the connection, and this is the MAC address of destination where packet was delivered. And in frame layer, it displays metadata like when packet was captured, packet size, and all other relevant information. Alright, so these four layers basically determine how two computers are connected and how they are exchanging data. Alright, in most cases you are likely to see fifth layer as well. So if I select the TLS packet, as you can see here, we have this TLS layer. So this fifth layer basically displays the type of data we are exchanging. Filters allow you to find the exact packets or information you want to see. By default, Wireshark captures all types of packets. So it makes it really difficult to find the packets you want to see. So to overcome this problem, filters were introduced. Filters basically remove unnecessary packets from your list and only display packets you want to see. Obviously, we will learn all the important filters in a few seconds, but before that, we need to understand different types of filters. There are two types of filters, display filter and capture filter. Display filters are used for filtering through already captured packets. For example, here as you can see, we have all these captured packets here. You can apply display filters here to filter the packets you want to see. And capture filters, as the name suggests, are used for filtering packets during capturing. Let me simplify this. We already know that Wireshark by default captures all types of packets, but let's say you only want to capture TCP packets or HTTP packets and nothing else. That's where capture filters step in. So capture filters let you decide what type of packets you want to capture. So before starting Wireshark session, you can tell Wireshark what type of traffic or packets you want to capture. Once you set the capture filter, then Wireshark ignores everything and only captures packets according to your capture filters. We will cover how to set up capture filters with two different methods later in the video after covering display filters. Now let's implement filters practically. So this is the filter bar where you can write your filters. So write UDP. You can notice one thing, as soon as you write the correct filter, background automatically changes to light green. If you write an invalid filter, then background changes to light pink. So all this is happening in real time. So this is a real help. Now in order to apply filter, either you can press enter or simply click on this arrow here. As you can see in protocol column, all the UDP packets have been listed here. In order to filter TCP packets, write TCP, press enter, As you can see now, TCP packets are being shown here. Basically guys, in this filter bar you can write all the possible networking protocols. For example, write ARP, as you can see, FTP, press enter, SSH. Basically guys, I do not have SSH and FTP traffic, so it is not showing up anything. Now let's say you want to combine or merge multiple filters. For example, let's say you want UDP packets and you also want TCP packets as well. So write OR operator and TCP. Now what basically we are telling Wireshark here, if you find UDP packets or TCP packets, then fetch them all. Press enter. Now as you can see, all the UDP and TCP packets have been listed here in our display area. You can combine as many filters or protocols you want. For example, or ARP or TLS, press enter. Now write HTTP filter basically filters HTTP traffic. Press enter. For now I do not have any HTTP traffic because I haven't visited any HTTP website, so it is showing up nothing. Now in order to filter the HTTPS traffic, if you write HTTPS, then it is going to throw an error because this is not a valid filter. In order to filter the HTTPS traffic, write TLS. Press enter. As you can see now, TLS or HTTPS traffic is being listed here. Basically this TLS is the extended version of HTTPS. Only difference is it uses a stronger algorithm to encrypt the traffic. Alright, in my opinion, the most important filter is IP address filter. IP address filter basically allows you to filter traffic according to the IP address. For example, let's say you only want to check the packets sent and received by a particular IP address. Then write IP.addr, write equal to sign 2 times and write the IP address. So this is my own IP address. If I press enter, now guys, it is only going to display the packets sent and received by this particular IP address. Alright, as you can see here also guys, you can use OR operator. You can basically check traffic of multiple IP addresses. All you need to do, just write OR operator and a different IP address. Now let's say you only want to check the packets sent by this particular address, then write src, press enter. Now in the source column, as you can see, it is showing all the packets originated from this particular IP address here. And change source to DST. DST basically displays the destination where all the packets were delivered. This destination basically displays all the packets received by this particular IP address, as you can see in the destination column, and these are the IP addresses where this address received packets from. And guys, we also have another method for filtering packets. You can also use port numbers. For example, write tcp.port equal to, let's say, 443, press enter. Now it is listing all the traffic received by port number 443. So let's go for 80, which is HTTP port. Now we have another very important filter called contains. So write TCP contains YouTube, press enter. Now what this contains filter does, it will go through all the packets and list out only packets where it finds the word YouTube. Alright, as you can see, it has found a packet where it found the word YouTube. So click on packet. Down here in our packet byte panel, you can find the word YouTube. So let me scroll down. As you can see here, www.youtube.com is being displayed here. If you want to further investigate who visited this website, then you can check out the detail panel. Here you can see this is the IP address who visited youtube.com, and this is the MAC address of computer who visited the youtube.com. So guys, contains basically filters out traffic according to your search term. So guys, you can use multiple port numbers to filter the traffic. For example, let's say tcp.port inside these curly braces you can write port numbers. Let's say 12, port number 443. You can write as many ports as you like. Alright, press enter. Now what it is going to do, it will list out traffic received by the specified port numbers. Now guys, let's learn how to set up capture filters. There are two methods for setting up capture filters. First one is you can specify the capture filters at the beginning when you start Wireshark. So let me close my current file. Now here, as you can see, enter a capture filter. Remember guys, capture filters are a bit different syntactically from display filters. If you write HTTP, this is not going to work. In order to capture HTTP traffic, you have to specify the port number. For example, TCP port 80. Alright. For HTTPS traffic, you can write 443. You can combine multiple filters like this, or let's say port number 80. Alright, so guys, this is the first method of setting up a capture filter. Second method is much more convenient. So let's learn how to set up capture filters and learn more capture filters with second method. So guys, at the top you can notice capturing from Wi-Fi TCP port number 443 and 80. It is only going to listen traffic of port number 80 and 443. So second method of setting up filter is, let me close my current session, go to the capture, click on options. Here you can specify the filters. As you can see here, capture filters. Let's say you only want to capture traffic from a particular IP address. You cannot use IP.adr, filter here. This is not going to work. You have to use host, then write the IP address, just like that. Alright, now it is only going to capture traffic from this particular IP address. You can combine multiple filters here with OR operator, just like we did with display filters. Okay, as you can see, if you click on start, then it is now, as you can see at the top, it is going to capture traffic going through these two IP addresses. You can also specify the port range. So write port range and specify the range. I want to capture from port number 10 to port number 443. Now it is going to listen traffic in all the ports between 10 to 443. Alright, so make sure to put a hyphen in between port range. Alright. So that's it for this tutorial. Again guys, thanks for taking your time and watching the video. I'll see you in my next tutorial.